So this lesson is going to be on square roots. And as you can see, the square root symbol is on the screen right there. Square rooting is actually the opposite operation of squaring a number. The question could be, given a square with an area, what is the side length? So here's some examples. So for this first square, if the area was 36 meters squared, what would that make the side lengths of this square? Or what would you have to multiply by itself to get 36? Well, the answer for this one would be 6 meters times 6 meters. Okay, so that means that the square root of 36 is actually just 6, because 6 times 6 gives you 36. For this next square here, if the area was 25 centimeters squared, obviously the sides are the same length, so what times by itself would give you 25? Well, that would be 5. In this case, centimeters, 5 centimeters. So the square root of 25 is 5. So if you just look at a number without the square, it works the same way, but you'd ask yourself, what number, when multiplied itself, will give you this original number? So if your number was 64, okay, you're finding the square root of 64. What multiplied by itself would give you 64? Well, the answer would be 8 times 8. So that means the square root of 64 is 8. All right, so the question is, how do we find the square root of a large number without using a calculator? Well, one method is to use a tree diagram. Okay, so the first thing you need to do is your tree diagram for the number. Then we're going to take each prime factor of the number and try to group them into two identical groups. Multiply one of the groups together, and this would be your square root. So let's just go through that with examples. Okay, so this tree diagram for 196. So we always find two numbers that will multiply to give me the number above. So in this case, I know it's an even number, so I'm going to use 2, and that would be multiplied by 98. So 2 is a prime factor, so that one's just going to stay the same. 98 is not prime, so I'm going to branch down from that and see what multiplies to give me 98. In this case, 2 times 49. 49 still is not a prime number, prime factor, so we're going to come down from that, and it would be 7 times 7 gives you 49. So now, we've gotten down to the prime factors on the bottom of each branch. So we're going to take these prime factors, only the ones at the bottom of each branch, and we're going to write them together. So this would be 2 times 7 times 2 times 7, and make two identical groups. So if we group them together, like I've done, 2 times 7 and 2 times 7 are identical groups. So if we multiply one of those groups together, we get the square root. So 2 times 7 is 14. Okay, so 14 times 14 equals 196. So this means that the square root of 196 is 14. So that's an example for that one. We'll try another one here. 144. Might have to write a little bit smaller. So if you use different factors to multiply to give you the higher number, that's just fine. You'll end up with the same tree diagram anyway. So we could go 2 times 72. You might recognize that 72 is 8 times 9. Okay, now we're going to branch off of each of these because neither of them are prime. This would be 4 times 2. This would be 2 times 2. 9 would be 3 times 3. So I'm going to take all of these prime factors at the bottom of the branches. And I'm going to group them together in two equal groups. Okay, I'm going to try to write that down here. So 144 equals, I have 4 2s and 2 3s. So I'm going to go 2 times 2 times 3 times 2 times 2 times 3. So now I'm creating two identical groups here of prime factors. So 144 would actually equal 12 here times 12. So the square root of 144 equals 12. So that's how we're going to find the square root of a perfect square using tree diagrams. If you can't create two identical groups like that, that means that the number is not a perfect square. So that's all you can do. So here's a couple more numbers that you can give a try of finding the square root of. So use your tree diagram. It might be a good idea to estimate first to know kind of where in the ballpark the square root should be. So you can pause the video now and try those. Here's a challenge problem, a word problem that uses square roots. So if you've finished practicing already and you want a bit of a challenge, you can try this one.